Hi there, in this video we are going to go over how to find and compare theoretical and experimental probability. Okay, so first things first, you have to know what a uniform probability model is, and that states that each outcome has an equal probability of occurring. So for instance, if you were to spin a wheel to win a prize, that is a uniform probability model where each section is equal, right? Theoretical probability is what should occur in an experiment, okay? What should happen? So theoretically speaking, if you were to flip a coin 100 times, 50 of those outcomes should be heads, and then the other 50 should be tails, right? So 50 out of 100 would be heads. Experimental probability, that is based on relative frequency, and relative frequency is just a fancy way of saying when you tally or take your data somehow after or during conducting of the experiment. Okay, so the experimental probability is what actually happens in the experiment. So let's say that you don't get 50 out of 100 heads, you get 47 out of 100 heads, and then let's say 53 out of 100 tails. That would be your experimental statistics, 47 hundredths and then 53 hundredths, not 50 out of 100. All right, so here's example 1. The graph shows the results of an experiment with a spinner with 3 equal sections is spun 60 times. Find the experimental probability of spinning red in this experiment. Okay, so we are going to focus on the red. And experimentally, right, during our experiment, it landed on red 24 times out of the 60 total times that we spun the spinner. Okay, and this, if you actually divide by 12, you do get 2/5. So your experimental probability is 2/5. 0.4, right? If you divide 2 divided by 5, you get 0.4. Then if you move this decimal point 2 places to the right, you end up getting 40%. Okay, and next it says compare the experimental probability you found in example 1 to its theoretical probability. Okay, well before we can compare, we need to figure out what is the theoretical probability. So let's just say we have this spinner, okay, and we have a green, a blue, and a red section. Okay, let's focus on the section that's red. That is 1 out of 3. Okay, so your theoretical probability would have been 1 out of 3, or 0.3 repeating, or 33.3 repeating percent. Okay, so there's our experimental probability in red, our theoretical probabilities in green. So when you compare 40% and 33.3%, well, I mean, they're actually pretty close, right? 40% is close to 33.3%. So I would say that our experiment here is a success. If we were to continue on with the experiment, I do think that we would get closer and closer to our theoretical probability, which is 1/3, or that 33.3 repeating percent. Okay, next example. 2 number cubes are rolled together 20 times. A sum of 9 is rolled 8 times. What is the experimental probability of rolling a sum of 9? Okay, so let's see here. The sum of 9 is rolled 8 times. So 8 out of the total, which was 20 times. Okay, if you want to simplify this, you could divide each by 4, and you would get 2/5. Okay, so your experimental probability is 2/5, or 0.4 if you divide 2 divided by 5, or 40% if you move the decimal 2 places to the right. Okay, that's your experimental probability. Now your theoretical probability. So theoretically speaking, if you were to roll these two dice, theoretically speaking, you should be able to land on 9 this many times here. Okay, that's why I have this table here. So a 3 and a 6, that'll get you a 9. A 4 and a 5, that'll get you a 9. A 5 and a 4, that'll get you a 9. And then the 6 and a 3, that'll get you a 9. You can also think of it like this. In this table here, I have a 9 here, 9 here, 9 here, 9 here. Those are the different outcomes, different ways that it could land on 9. So that's 4 ways out of, if you were to count all of these outcomes here, there would be a total of 36. Okay, and this actually, you can divide each of these by 4, and you get 1 out of 9, or 0.1 repeating, or 11.1 repeating percent. Okay, so if we were to compare, the experimental probability is much greater than the theoretical probability. There might be a discrepancy because the dice was only rolled 20 times and there are 36 different outcomes. If you have more trials in your experiment, then your experimental probability would be closer to the theoretical probability. Okay, so make sure that when you conduct your experiment, you do it a good number of times. I would do it at least 36 times since there's 36 different outcomes. But yeah, 100 times, 200 times, anything is better than, anything more than 20 is better than 20 times. Okay, and in our last example, so Joe Quinn kept track of players and winners for his game during the fair. Based on the results in the table, how many winners should he expect if 300 people play his game? Okay, so let's look here in our table. So we have from 10 a.m. to noon, there were 28 winners out of 174 players, which turns out to be 16.1%. From noon to 2, there's 43 winners out of 242 players, so 43 out of 242, that's 17.8%. And then your total, which is what we really want to focus on, there's 71 winners and 416 total players, so 71 out of 416 gets you 17.1%. All right, so there's 2 ways that you can do this that I would really suggest. The first way is a proportion. Okay, when you set up your proportion, you would set it up as winners to the total. So here, your first ratio of winners to the total would be 71 to 416, which is what I have here. Okay, and then you're going to put your unknown, which is X, right? Is the number of winners. We don't know what the number of winners are, so we'll put X here out of 300. All right, and then you just cross multiply to solve. So again, you're setting up your proportion as winners to the total. You're given this ratio in this table here, and then this you just came up with because you're trying to find how many winners, that's why this is X, over the 300 people, that's your total. All right, so if we go to solve, 71 times 300, that would get us 21,300. And then if we do 416 times X, we get 416X. Okay, I am going to continue solving this up here. So 416X equals 21,300. Okay, you would divide each side by 416. Then you get X is equal to, let's see, 21,300 divided by 416. You get about 51.2. So I'm going to say about 51 winners. Okay, the second way you can look at this is, okay, well, you know that 17.1% of the total are winners. So what you could do is you could find 17.1% of now the 300 people playing your game. So what you would do is you would move the decimal 2 places to the left. So you would have 0.171. The of turns into multiplication times 300. Okay, and then when you go to solve that, you do get about the same thing, which is about 51 winners. Okay, and now next, how many winners should you expect out of 500 players? Okay, so we have our ratio again, winners to the total. So 71 out of 416, that's given to you right here in the table. And then we have this x out of 500. That is how many winners, so that's x. X out of the 500, this is your total. Okay, that's where we got that from. Okay, and now we can go ahead and solve this proportion. So we would do 71 times 500, which that gets us 35,500. Okay, and then you would also do 416x. Okay, so I'm just going to continue solving this over here. So we've got 416x equals 35,500. Okay, divide each side by 416. Okay, now you have x is equal to about 85 winners. Okay, and then the second method that you could do is, again, you could find 17.1% of 500, right? So now your total is 500. So we would move this 2 places to the left, so we would use 0.171 of means multiply by 500. So 0.171 times 500, and that gets us the same thing, about 85 winners. Alright, so that is all. Hopefully you learned how to find the theoretical and experimental probability. Thank you for watching.